Well, good morning, good afternoon, good evening, depending on where you are in the country, in the world, or whether you're watching this live or on repeat. It's much better live, actually. You should join us. Everybody's here already. I'm going to go round clockwise on my screen. So first of all, we start with Rob Jones. Hello, Rob.
Hi, Ian. How are you doing today?
Doing very well. You can give out your job title if you like, but I haven't got it on your little thing down here. What is it you do?
Well, I do a bit of everything. My job title is solution architect, but essentially getting down in the weeds with all the technical aspects of Yellowfin and helping customers to get the best out of the product and get ready to
Badly
use it.
worded by me. That's what it was. What do you do? Yeah, I should have said what do they call your job titles? And going round again, the next is Montana. Hello, Montana. How are you?
Hey, Ian, how are you? I'm solutions architect, just like Rob. Swiss Army knife, as I call myself, just a little bit of everything.
Oh, see, people expect you to speak with some kind of German Swiss accent now. No, don't try it. You know there'll be people out there that go, I was very offended when Montana tried to speak with a Swiss accent. We don't sound like that. Yeah, it happens.
Yeah.
And finally, but not the least at all, is Stephen Ball. Hello, Stephen.
Hello, Ian. Hi, everyone. I'm pre-sales director for within the Idera DevTools division, which covers Yellowfin as well. So.
And I am just Ian, and I work for Idera, and Yellowfin is the parent company of Idera. So I turn up and I do things like this. I wave round bits of electricity to make the thing work. Okay, so getting straight down to it today, we did have a webinar last time where we didn't really get to all the points. We had a lot of slides, and Rob had worked very, very hard on them, and then we just went, oh, we're done now, let's move on, and that was it. Half his slides didn't get across. I think we thought they were quite important. I think we're calling this Learn the Lingo. That's right, isn't it?
It is indeed. That's the idea really of this. It's not a tutorial. We're not going to teach you how to do all of this stuff, but our objective really is to just share some of the vocabulary, some of the words that we use, get you familiar with some of the concepts. So at the very least, you don't feel you're in the wrong place when people start using them in conversations with you, and hopefully you might feel inspired to go away and learn a bit more, or bring them up in conversation with us in the future. We'll be coming back to some of these topics over time. So there's something takes your fancy, then let us know and we can bring that forward in the program.
This has really been inspired from comments that we've had from a number of calls recently, and also from a couple of the earlier sessions on the Analytics Coffee Club, where we're hearing a lot of developers who are kind of stepping across and being asked to implement and build and get involved with getting AI and BI embedded into applications. So from that side of things, it's really important that they understand the terminology that's going to be coming up. And it's also great for anybody who's new into an analytics team internally, just to kind of cover some of those terms that come up regularly.
Yeah, basically a little lexicon of what it's all about. I'm just going to make my border go away just 1 second. Oh, see, I'm going back to there. There you go. It looks a bit more professional. I'm just going to move. Just a bit of housekeeping here. Make this go to over here. Hold on 1 second. There you go. Yeah. Okay. So for those that are watching, if you scan that QR code, you would actually go to the Yellowfin site, which is kind of important. I mean, you can watch all the slides and listen to us, but at the end of the day, we would quite like you to go to our site as well. And it is also available here as well. I won't put these up on the screen all the time, but if you go to yellowfinbi.com, and the BI is quite important because obviously Yellowfin is one of those kind of slightly generic terms. If you Google Yellowfin, you'll get lots of fish turn up and various other things as well. But we are Yellowfin BI, standing for Business Intelligence. I think that's right. Yeah, I'm guessing that correctly. I've never really asked anybody what the full name means.
I think you're right.
Yeah. It sounds plausible. Okay, so Rob, I'm going to let you drive the slides in, so to speak. I am now your Siri, or whatever we would like to call myself. There's going to be a brief flash once I get this up. Okay, over to Rob.
Let's jump forward a slide to the agenda slide then, Ian.
Okay, Maria's not with us. She'll be with us another time. She's off doing something vitally important.
So these, we're looking at the slide here. So here we've got the broad topics that we're gonna touch on today. Last week we kind of got to somewhere in the middle of dimensional modeling. So what I suggest we do is we'll have a quick recap of the first two, and then probably spend a little bit longer talking about in some detail about the later ones. So let's skip to the first slide. Say, what is business intelligence? I mean, at the end of the day, as I found out, was reminded on a call the other day, it is perfectly possible to have worked with data, even been writing SQL queries for, as the chap I was talking to said, 20 years, and yet still not quite be familiar with a lot of the lingo that we're trying to explain in today's call. And so it's worth taking just a step back and saying, well, what are we really trying to do here? I do like to say business intelligence is all about doing business intelligently. It's about using the data that you've got within your business to help everyone within that business to make better decisions. And the whole practice is all about, well, how do you do that? Making sure you've really got the right information, working out what their job entails in terms of the questions that they need to be able to answer, and thinking about what data could you present to them at the moment they're making those decisions to help them to make better decisions. And that's really what we're trying to do with business intelligence. And in the next few slides, what we'll be talking about really is some of the nuts and bolts of how you can make that happen. So let's progress maybe to the next one. And what is the that? There's a little bit of a history of business intelligence, really. This particular model was originally put forward by Gartner quite a while ago. I've forgotten the date, but it's several years back. And it's actually a really good model. I really liked it at the time, and it stood the test of time. And what it says is, when you come to using your data, the first thing you do is you start asking questions about what happened. So you're looking backwards, you're saying, what does this data tell me about what's actually happened in my business? And this is the kind of the standard reports that you produce that says, we sold this much of that product last week and that much the week before, or we've acquired a new customer last week, or we've billed these customers, all that sort of static stuff, maybe financial reporting that comes out perhaps once a year, and it's there, it's the truth, as best you can work it out, but often it's kind of the end of the story. It's like you present it, people will go, yeah, that's interesting, and if they're really inclined, they might start trying to drill into it, and if they do, that's where then we move on to the next step, which is to say diagnostics. So you say, well, great, I sold that much last week, but why did I sell less last week than I did the week before? And that's the point where you start asking follow-up questions. Now, in the past, that would have meant a phone call to somebody who could give you the answer. But business intelligence tools now, for quite some time, if you're honest about it, have helped you to drill down into the data. And drill is one of the technical terms that we like to use. It's actually typically navigating some kind of hierarchy, whether that's a time hierarchy, looking at maybe you might start looking at data for a whole year and then drill down into quarters or months or weeks, and that's all within the data. So you're exploring it. You can also drill down maybe a product hierarchy. So if you've got product categories, subcategories, right down to products at the bottom of that stack. So it's diving down to more granular data. So granular is a word that will come up a few times as we go through this. It just means talking about you're getting more detailed data, and the grain of the data is actually a term that we often use to describe where you are in all of the various dimensional hierarchies. Now, I'm aware I've used a word there that we'll talk about in just a moment, but dimensions, think of it in terms of dimensions of the problem. So it's like, what I want to analyze my data by is, to steal my own thunder from the next slide, I think. So if I'm talking about sales, I want to know sales by product category. Product category is a dimension. If I want to do it by time, again, time is a dimension. I might want to do it by location. Again, that would be a dimension. So just hold that in mind. So diagnostic is still sort of exploring the data in a I can navigate around it and so on. And then, in various times that might be generating SQL queries, or you might be using an OLAP cube or something of that sort, but you're still just poking around in the data, looking at what happened. The next kind of obvious thing to want to do is to say, well, how can I use that data to help me understand what's likely to happen next? And that's really where you can get into predictive analytics, and that's a whole space in its own right. I mean, you can do really simple analytics, which is like, well, look at the graph. It's going up at a straight line. Is it likely to continue doing that? Well, yeah, it might well do. And you can kind of do things called linear extrapolation, best fit modeling, and that kind of stuff. And Yellowfin can help you do some of that in terms of taking a graph and just seeing, well, where's it likely to go based on just the data in that graph. But predictive modeling more generally is a much more complicated space. I used to work in retail, and the number of dimensions that we used to analyze to try to predict what was going to happen to sales, and hence how much we would have to order over the next week, month, year, was really complicated. And it involves some pretty heavyweight analytics tools, things like programming in R and Python and SPSS,
Wow.
and other stuff. So, I'm not saying I did that, but it was there. I was the architect. So that was somebody else's problem. But you had to know how it all fits together. And the way it fitted together then, and I don't think things have really changed, is that you would use those tools to generate the data. And the data is what is our forecast for this metric at this date in the future, and that date in the future, and the date after that in the future. And you can load that into a database, and then you can put that alongside actual data, maybe your orders, or recommended orders. So in fact, you might look at the predicted sales and say, right, well, I'm going to recommend, and now we're starting to stray into box 4 over here, the prescriptive stuff. So, well, if that's what we think we're going to sell, I suggest you order this much, which might be 10% more, just to allow for wastage of various kinds.
Shrinkage. Yeah.
So that's the kind of the full spectrum. We've gone from what happened, why did it happen, what do I think is going to happen next, and then finally, what should we do about it? And in fact, there is arguably a fifth one, which is taking it a step further, and that's now we're starting to get into agentic business intelligence, which is saying, well, don't just tell me what to do, just go do it. Once we've reached that point, I'm going to stop talking to you, because we won't have a job anymore, and it'll all just be happening. So I'm not going to worry too much about that, but it's kind of the next step.
You've just ticked the AI bingo card by saying that so it's going well. You've got 3 more, and I think you get a full line across. Yeah.
But I think it's really interesting kind of looking at this in this way, because I think the most important part on this slide is the bit at the bottom that says increasing business value. The whole reason for kind of looking at this is it's about trying to get that value back into the business to be able to understand what's going on, so you can make informed decisions. And that goes back to what Rob was saying at the top. It's all about trying to make informed decisions. Now, one thing just to pick up on this is, I think for a lot of developers who are used to using reporting components or elements to show tabular data or to list out basic reports, they're right the way on the left-hand side here. They're very much saying, this is what's happened, and here's your data, so you know what you've done, and then you can look at it. Where the BI platforms really come in is that flow through to the increased value on the right-hand side. And there's so much, as we've touched in other sessions, that come into play around that with legislation and stuff like that as well, that it's a real kind of minefield, and something that's often better to buy versus build. But that'd be a topic for another session, another day. So
it will, although it leads on nicely to another term which fits that description, which is around embedded analytics. So I think I said it last time, but it bears repeating, which is that our view of embedded analytics is that there are 2 ways of looking at it. On the one hand, it's about literally just embedding graphs and charts into your software, and that certainly is one kind of embedded analytics. But take a step back and ask yourself, well, why are you doing that? Why do you want that particular graph or chart in your software in the first place? And it's all about helping the user of that software to make better business decisions. So understanding what those decisions are, what is the workflow that you expect them to be carrying out, and thinking about the graphs and charts and other information that you want to put in front of them at the point that they're using it is really what we mean by embedding analytics. So let's skip on. So all models are wrong, but some are useful. Why did I put that in? It's a cool quote, and it's certainly true in the BI world. I mean, what you'll find whenever you come up with your first stab at coming up with a dimensional model, figuring out what you want to analyze things by, is usually wrong.
Oh, he dropped off.
He's dropped off. Well, I think it actually leads on really nicely to actually moving on to the next slide then, which talks about...
He's come back. He's come back. There he is.
Well, maybe models aren't all wrong.
Yeah,
Just
the model went
The
analytics.
model struck back and I was censored. It's really saying, when you're doing the modeling, it's all about starting by saying, what questions do I need to answer? And it's not you as the developer, what questions do you need to be answered? It's your users, your business folks, what questions do they need to be able to answer? And hence, what information do you need to provide to them? But when you start drilling into that, there are the devils. The devil is always in the detail. And when you start trying to take your real business information and, what should we call it? Effectively shoehorn it into a data model of some sort that you're trying to define, things usually go wrong at that point. So where you thought things were really simple, and well, everybody knows what I mean by location. Years of my career were spent discussing what we really meant by location in retail, and it's like, well, you think it's obvious, isn't it? But actually, no, it's not. It could be a store number. It could be a physical store location. Actually, what do you mean by a store anyway? And this is where you can easily spend a huge amount of time trying to figure out what exactly do these words mean, what did the business users mean when they used them, and trying to then make sure that all of the various things which you come along and say, well, I think it's a store, but is it really a store? Do I need another dimension to represent what distinguishes this kind of store from another kind of store, and that kind of stuff? And you can go around a lot of iteration of that, but that's refining the model, making it more suitable for use to answer the kinds of questions that your business users have. And it's always the case that when you give them the first cut model, they'll come back to you with more questions, and you usually have to then expand the model, refine it with additional information. So I mean, here we've got a supermarket example. Obviously, I spent a big part of my career this one in this area really well. Products you typically would break down into categories, subcategories, and then individual products. You might have a whole bunch more levels in that hierarchy. And in fact, there are some now some standard categorizations that are used by most retailers and so on across the world, sort of GTINs, global trade identification numbers, and a whole hierarchy above that I'm trying very hard to forget. But it was very useful having that standardized hierarchy. And you'll find the same thing if you go to medical data. There's again standardized vocabularies, the standardized hierarchy of conditions that you can use to make sense of your data. I'm not even sure.
The most important product category for me is chocolate, Cadbury's, dairy milk. Obviously, other chocolate brands are available.
Cereal.
Very important categories, yes. Of course, the Swiss might debate whether that's really chocolate at all, but we won't go there. Vegemite. Remember that debate when we were still in the EU, Stephen? It's like, you can't call that chocolate, it's not real stuff.
Come to America and eat Cadbury's chocolate, and you'll be realizing that even if it's called Cadbury's dairy milk, it doesn't mean to say it's the same thing. There are two categories. There's American and British, and they're not the same.
That's true.
Yeah, fun stuff.
We've got our data. We've got our data model, or first cut of it anyway. So we're going to talk about sales. I want to know about my sales, how much I sold, where I sold it, and all those sorts of things. It's a relatively simple model that we'll start with. How am I going to store that in my database? Because I'm going to need to store it somewhere in order to be able to use a BI tool with it, and that's going to be some kind of database. We'll touch on what kind of database a little bit later in terms of the tech stack and so on. But for now, we'll just say any relational database, be that Postgres or Exasol or SQL Server, any of the sort of common ones. But yes, you're storing it in tables, but exactly what shape are those tables? So let's just move on to the next slide, Ian, if we can. So again, one of the important terms that we use a lot is a star schema. And it's called a star schema because it kind of looks a bit like a star with a star in the middle and maybe planets around it or something of that sort. It has a central table, which we usually call the fact table, and that describes the thing that we're measuring, in this case, the sales object. But I mean, it could have been orders, or it could have been stock level. Stock level is a fun one, so let's not go on that at the moment. It might be... well, whatever your business does, it's likely to be some metric of how much of it have you done. So something measurable, and then you want to analyze it by the dimensions, which are then represented as their own tables around the outside. Now that's a simple star schema. If you start to find that actually there's more information than you really want to hold on a single table, you sometimes expand that and start to talk about a snowflake schema, and there you might have additional tables kind of chained off the dimension tables, providing more detailed information about those dimensions. So
the example I always give for this kind of scenario is if you're an office equipment manufacturer, so you make desks and you make office chairs, and usually the concept of stock is not the same as the concept of raw materials for the stock. So, for example, you could have 1,000 ready-made desks, office desks ready to go, but actually that's your finished stock. That's what you've got ready to sell or what you've got ready to ship. Maybe you make them to order, or maybe you make them preemptively because hey, there's a big company opening and they're going to have so many tables I want to buy. But in order to make those in the first place, you also need a stock of raw materials, and that's where the concept of actually a snowflake scenario comes up, because 700 feet of wood, or however people manage that, so many square meters of wood or so many pounds equals so many desks. How much your wastage is when you cut a desk to 6 feet wide by 4 feet across or something like that. That in order to do that you need a certain amount of wood if you're using wood, or plastic if you're making a laminate type equipment, and those all feed together, and that's actually a more complicated formula than you'd imagine. Take, for example, Windows. I used to work on Windows, not Windows as in the things that you look out of, not in the things that you click in computers. I used to work for a software company that used to write glass estimating software, and it's an art form, because if you've got a brand new office building, offices do not have completely uniform windows, and even when you say I've got a window that's so many feet across and so many feet high, or centimeters and meters if you're European or something like that, even those, there's about the depth of the window, therefore you need more glass if it's going to be double glazed, or it's going to be, God forbid, bulletproof or something like that. If it's a bank, maybe you might have bulletproof glass. They tend to be specialist manufacturers, but all of that process, estimating, again, goes into your star chart of how many more raw materials do I need in order to create a sellable stock, and also my shrinkage. Because if you make windows and you transport them, every 5 journeys you get broken windows. They're very, very good at doing it. They break fewer windows than you or I would do, trying to buy a window, put it in the back of a truck or something we've rented. But even so, it still happens. You get contract fitters that fit them, and something happens, or there's a hail storm, and
Windows breaks on me.
Yeah, this is the Linux guy. Yeah, I think that's a definite diss on Windows, the operating system. But yeah,
there's a couple of
things. A cracking reputation as a developer in. Is it the background?
Cracking. Oh God. Oh,
it's all becoming crystal clear.
You're just chipping away at my reputation, aren't you? I can just see you're very transparent. I can see what you're doing.
I can see right through you.
Oh God! Here we go. We need to get back to Rob before we just turn into a complete Monty Python sketch. We did say this would happen as well before we started, and lo and behold, 3 Brits together. And I suppose I'm half a Brit actually. It's 2.5 and 1.5 Americans. There you go. So. Anyway, Rob, sorry, you were talking about snowflakes before we kind of digressed a little bit there. But that was an example, again, of a kind of snowflake distribution of schemes for data and things like that.
And you raised a couple of interesting points in there. So, I mean, one of the things that you touched on was a kind of bill of materials topic, which was almost saying, right, well, product, what is it you're selling, what is it you actually buy. They're not necessarily the same thing. And why is that important? Well, first of all, there is some structure that you can have in terms of, well, this product that we sell, what is it made up of? If you want to go down the route of saying, what did we buy? Well, the answer is I didn't buy any of that because I bought the things that I made it from. And so that you've then got to think about, well, how can I put that into this schema? And sometimes in the past, people very often did try to do that. And they would have within this, instead of having a fact, it would effectively be a multi-fact. So they would have not just sales, but also orders. And if we're on a bet in retail, that still makes reasonable sense because most of the products that we sell are also the same products we buy. We might buy them in slightly different quantities. So the metrics, the things that you measure for that product could get quite long. So rather than just sales value, you're saying, right, well, okay, how many cases of that did I sell? Actually, you'll have something like a unit of measure. What am I selling it by? You'll have an order unit of measure. What do I order it by? And that might be units, cases, kilograms, liters, whatever it is.
Retail has a very interesting term, as I recall, which is shrinkage, which is another factor that goes into it. When you sell goods in a retail environment, you have shrinkage of stock. And shrinkage is a great term because it means multiple things. Shrinkage can quite often refer to theft, outright theft. If you have 25 bottles of vodka, maybe you only end up with 24 because one of them disappears, and it's usually because your local guy, with a big hoodie on, or whatever clothing is appropriate, has spirited it away. Or the other shrinkage is while they're putting them on the shelf, they drop the bottle of vodka, and the bottle of vodka is ruined, and that's shrinkage as well because you've got so many in stock, you sold so many, but one of them couldn't be sold because the person putting it on the shelf dropped the bottle, or the shelf collapsed and all the bottles broke. And the final shrinkage is someone miscounts. So when you're taking a stock take and you get in a delivery of 5 cases of vodka, actually what you get are 5 cases that are full and one case that's empty, or you get 3 cases that have not got the 12 bottles in it should do. And that's another form of shrinkage. You count the cases, I've got N number of cases and the 12 bottles or 24 bottles each, but actually when you go to put them on the shelves, something's happened at the factory or someone has stolen one in transit, and you have shrinkage there. So there are some dimensions to data when you're selling volatile, and of course fruit and veg is even worse because some of the fruit is bruised in transit, some of it actually rots, some of it rots whilst it's on sale, and again, someone drops it on the floor and you drop a ripe tomato, using the British pronunciation, or tomato, drop it on the floor, it's ripe and it's ruined because it's effectively like your bottle of vodka, it's broken. So again, there's a dimension to these things that are not tangible. I've got N number of widgets and I'm going to therefore sell N number of widgets. In retail, it's far more complicated, hence the term shrinkage, because multiple ways to lose your money. Happy days.
So I think taking those kind of points, I think there's a really interesting point that can be picked up from that all, is that when you're putting an application together to record all of this, you might have lots of different tables to log different things, and you're gonna identify kind of foreign key constraints and this kind of snowflaking design within your application architecture. Obviously, we deal with a lot of developers who are coming in and trying to put BI in to work alongside their existing CRM systems. So, Rob, what kind of tips and advice have you got for people who are looking at taking existing products they've got, maybe databases that they've got a lot of transactional data in, to then start introducing BI on top of that?
So that's a good question. It's almost like you've been reading the slides. Maybe let's skip to that. So I mean, one of the key things really is that it's a good idea to capture as much data as possible, because, well, why is that? You never know quite what you're going to want. So we used to have a phrase which was if you touch it, take it. And what we really meant by that was when you're building your business intelligence environment, so your data warehouse, which is like your copy of the data. Copy is a fairly loose term here, but your version of the data which you're going to use for analytics. Usually that involves going to your source system, which might be an ERP or some kind of operational system. And you're pulling data out of that somehow, or you're calling an API to get it, or one way or another, you're getting it out of those operational systems. It's tempting to say, right, I'm just going to take the bare minimum that I need. I need one field, so that's what I'm going to take. But the advice is generally, well, no, don't do that. Take out everything you can get in that one go, and store it, even if you don't need it right now, because there's usually more effort required to build that interface than there is to process the data once it's in the data, once it's in your data warehouse. So take everything. If you've touched that table or that interface, grab everything you can at the same time, load it into some kind of data warehouse. In reality, what you'll be doing is loading it into something like a data lake or some kind of staging area. Just dump it all down, and once you've got it in the database, you can start processing it, cleaning it up, making it look like the data you need for your analytics and so on. So, I mean, what kind of data are we talking about? It's things like event. We've got on there. So an event is something that happens. So that might be I made a sale. It might be customer placed an order is some kind of sale, e-commerce sale. It might be that I placed an order as a business. It might be that something actually arrived at my warehouse. But it's an event that it happened at a particular point in time, and you can capture information about it. So I mean, if it's a sale, well, as we touched on, you probably want to know, well, where did I sell it? How much did I sell? What price did I charge for it? Those are the things that you can actually record about the event itself. Now, your sales table in your data warehouse might be using things that aren't in that original sale. So you might be enriching that information somehow. But it's really important to capture the actual event, as much data about the actual event as you can, and bring that into your data warehouse, because you can then use it in flexible ways and change your mind about how you want to use it later. So capture it, store it. Another kind of metric or another kind of thing that you might want to store is we call it metrics, but if you've got think Internet of Things sensor data. So if you've got a temperature gauge in your fridge, or a temperature gauge in your office room and so on, and you're regularly capturing that data, it'll come out with some kind of cadence, whether that's every minute, every hour, or even every second if you want that. You can capture a lot of information about it. What was the sensor ID? What was the actual value that it came through? And the temperature is probably not that much, but you capture all of that, and you can aggregate it and turn it into something useful. And it's the aggregating that's interesting. The individual reading is like, well, yeah, that's just history. But you can look at the trend that's happening there. You can see whether it's even, whether it spikes at certain points, and then you can start looking for, well, does that correlate with something? And who knows? One of the interesting things is, what can you infer from that? Well, it might be something like the temperature sensor on my fridge, or my not fridge, perhaps my chiller cabinet. Suddenly went up at that point. What does that mean? Well, somebody opened the door, didn't they? That might be interesting, and it might be the only way you can tell that somebody opened the door. I mean, it's not the only possible explanation, but actually, if it's an example of how you captured information for one reason but found another use for it, and that's very common as well. So another good reason for capturing as much data as possible.
Derek was locked in the fridge.
Yeah, different kind of problem.
I used to happen all the time when I first left school and worked in a grocery store. Butchers would always be ending up locked in the butchery fridge, and there was an internal catch to get out, and for some reason they could never open it.
They're too cold.
Nobody died, by the way. Nobody was harmed. They were just.
I think that mechanism was probably frozen.
Oh, yeah, well, yeah, possibly. Yeah, the puns are coming thick and fast. They're very impressive so far.
Yeah, I was going to say, you mentioned a couple of phrases already about data lake, data warehouse. I think one of the other things that I've heard mentioned by developers in the past as well is denormalizing data. I think that's certainly where you've got maybe you regularly want to report against, say, a list of sales transactions, and you want to know who. You might have a pointer to the person, which has got a lot of information about them, but you might just want their name on there, which is used 90% of the time. So it might be that field gets denormalized onto the transaction as well, which can help kind of alleviate some performance challenges where instead of having to have joins all the time. But at what point do you kind of look at moving from your data in your normal database and into having a data warehouse or a data lake.
So there are quite a few points in there. Let's just think about the best way to step through this. So the data lake is usually the place where you're storing information. It's the place where it first touches your data platform or your environment where you're managing data for the purposes of analytics. You don't always know exactly what you're going to do with it, because I mentioned the touch it, take it principle, which is, says, right, well, whatever I can get in there, I'm going to put in there, basically. And our data scientists will often say, just give me as much data as possible. I'll figure out what I need later. So you shove it in the data lake. Don't worry too much about organizing it. Just make sure you capture as much information as possible about where it came from, when you got it, and those sort of things, so that you can then start to assess the quality of it later. Because if you just store the number without what we call the metadata about it, then it's going to be really difficult to figure out, how useful is that, and so on.
It's probably important as well. Can I just? Oh, where's my camera? My camera just paused for a second there. It's probably important as well to hello, computer. My camera is flipping out on me. That never happens. What have you done to me? It's probably important as well to mention that we explain what you mean by data lake, because actually that's a slightly what's jargonish term for what you're talking about. So maybe just explain, when you say putting it into the data lake, what exactly do you mean by that?
So the data lake is the area where you haven't yet done any, you've made no transformation. So when you land the data as it comes from the source system, typically that's the place that you put that into the data lake. Now, some people would say it's like completely unstructured data. It's like, personally, I think that's not the most helpful way of characterizing it, because I would argue if the data is worth storing, it's not unstructured, because it's really unstructured. You don't know anything about it. What the heck are you going to use that for? But it might mean, in some environments, it can mean things like image data, so actual images or videos or something like that, and
documents.
There are companies that really do want to perform analytics on that kind of data, and they have sophisticated tools for doing it. It's pretty niche. You can't do it with Yellowfin, so we won't get into that at the moment. But that is one thing that people can mean when they talk about a data lake, just throwing that kind of stuff in there. But for our purposes, it's really the place that you start organizing data. So you get it from your source system, you put it in the data lake. You then take it from there, or take the parts of it that you want, because you've identified a use for them, and move them through into the data warehouse. And I would think of the data warehouse as being the more tightly managed part of your data environment. So at that point, you've started to do things like make sure that the data you've got really fits all of the type checking, data quality rules, and so on that you might want to apply to the data. You make sure that you haven't got multiple copies of the data going through into your managed data warehouse, and you start to organize it. So I think on that, so you've got point 3 there. And what that looks like depends very much on which school of data warehousing you kind of you choose to follow. So the kind of the great fathers of data warehousing, people like Bill Inman and Ralph Kimball, and they had different views of the world. Inman talks very much about a single set of integrated tables. So you have a massive great data model where you kind of model your whole business, and you have a table for each individual fact, and it's all what we would call normalized, which means there's no duplication of information. Each table stores one kind of information, only one kind of information, and at least in theory, you shouldn't find that particular piece of information anywhere else in the data warehouse. Kimball, on the other hand, took a different view where you basically have a collection of star schemas. Each of those is a data mart, and your data warehouse is the kind of the umbrella term covering all of those star schemas. And they both work. And then a bit later on, a chap called Lindstedt came along and came up with a thing called Data Vault, which is actually probably one of my favorites theoretically, although I've never had never actually worked with it in practice. It looks really good, and a lot of people use it. And it's a way of organizing data designed to give you a lot of flexibility about how you process it. So The challenge is, as soon as you decide on your data model, you make some questions easy to answer and other questions are going to be much harder to answer or even impossible to answer. And Data Vault sets out to make as many kinds of questions as possible to answer. You would then often overlay one of the other kinds, well, probably a Kimball data mart on top of that, and we call that a business mart, which actually starts to answer the question. So you might have multiple different ways of presenting the information, which could be physically storing it, again, in different formats to support business use cases on top of the data vault. That's probably a level I wasn't particularly planning on getting down to, but it's worth knowing that there can be that complexity, particularly in an enterprise context where you're trying to cover all the different subject areas in your business. You're not going to fit everything into one star schema. It's going to be multiple star schemas one way or another, and might not even be a star schema, but ultimately, when you start wanting to ask questions of the data using pretty much any BI tool, you're going to, at the very least, there's going to be a logical star schema involved. And I suppose that takes us, we might as well cover off Stephen's question about denormalizing data. So denormalizing is kind of the opposite thing. Where I said normalized data stores each piece of information in one place only, denormalized is kind of the opposite. It says, right, well, I've got this logical star schema, but I don't want to have to join those tables together every time I want to answer a question, because that takes time and maybe costs you money depending on your database and where it's hosted and so on. So denormalizing says I'm going to pre-join the data. So I'm going to take a record which says I sold this, and I'm going to actually push down all of the information from maybe the product information and store that against every row in that database that says what I sold. So it incurs a lot more storage cost. It still might not be all that much money, but relatively speaking, you're storing a lot more data, but it can be much quicker to query and get the answers out of. So there are trade-offs there. It can be faster to query, and that can be useful. The downside, I suppose, is that by pushing it down onto the single table, the maintenance overhead can be quite high. So if a product changes category, for example, you've then got to go and find all the rows where that product occurs and update the product category value in that cell in your data, and that can be quite an expensive query as well. So if things move around a lot, denormalizing your data is maybe not the best idea. If it's relatively static, it can be a good idea to just store it with the data and make it quick to query.
So Stephen mentioned as well Warescape, which is why I put the address on the screen there. What was your take on Warescape, Stephen? Then?
Yeah, so we've got a presenters chat here, and I just pinged in the URL over. Warescape's one of the products within the Idera group as well, and Warescape is really quite cool. We've done a couple of blog posts with them in the past, talking about getting best of breed together. And one of the big challenges is around getting your data and the pipeline sorted to constantly feed from your data lake into your data warehouse, your data marts, making sure you've got that data consistently being updated into the format that you need ready to do analytics on. And Warescape does some amazing tooling for the automation and also the migration, literally picking which platform you want to put it on. And if as happened the other year, Oracle changed all their licensing setup, and you now want to move from Oracle to something else, because
very
it's all
quickly.
It can go ahead and move it. So yeah, if you're looking at that kind of higher end enterprise kind of architecture, then that's definitely something that's worth having a look at.
I don't do DevRel for them, but if I did, I'm afraid I would have to pronounce it Warescape. I really would have to do some kind of superhero. I have a picture up there that says, I have to say weird stuff or I'll die, and I really would have to say Warescape. But yeah, it's a great product. I mean, joking aside, Stephen and I both work effectively directly for Idera, which is why you'll see me promoting other brands, and Stephen as well. But Idera own quite a few companies, and they do pick some good ones, and Warescape is one of those ones that it's definitely worth mentioning for what it can do, I think, as well.
Yeah, okay. It's great because we get to touch lots of different markets that are feeding information around kind of the whole landscape of this, and it's great for kind of picking up those different things. So, all right, let's
still have to call it Warescape. I'm sorry, I would. Okay, all right.
We'll touch on where Warescape sits. It's a bit of an omission on my part, not having already put it on the slide, but it sits alongside. It sits Well, actually, there's a couple of places it could sit. So it can sit alongside Data.do over on the data ingestion pipeline. And that's a perfectly valid use case because it can be connected to certainly to all kinds of databases and so on. And I believe, although I'm not an expert on Wescape, it can also connect to some SaaS providers as well to pull data in. It's definitely sits underneath DBT, Airflow, and that's scheduled SQL is what that cryptic icon means. Effectively, it's saying, look, if you're regularly bringing in large amounts of data, you don't really want to be hand coding all of that. You want to use a tool to do it. DBT, I would argue, is probably the bare minimum. It's still very code heavy. Your coders will like it. Everybody else will think, it's still a lot of code. It's a bit slow to generate, quite hard to understand and debug and so on. Wescape is a graphical tool that you can use. It can actually work together with things like DBT because what it does is generate pipelines which can then be run in various other execution engines, things like DBT and so on. So it's a great tool, and if you're going to build a serious data warehouse or even a collection of data marts, you definitely need a tool like Wescape, whether it's and we'd obviously love you to buy Wescape because it's a system.
Lovely graphic, by the way, a very clear description.
Thank you. So I mean, this pipeline, the tech stack, really, the idea across the top, we're talking about, well, it's a pipeline. So if I want to do business intelligence, what have I got to do? I've got to get my data from data sources, pull it in, that's the pipeline here, into my data storage, and I put Exasol there. It could be something else. I mean, if you're going really heavyweight, a few years back, Hadoop was all the rage, and Hadoop might have been sitting under there.
Oh,
I've not personally come across anyone really using Hadoop for quite a while.
Well,
but
no one uses the elephant anymore.
I was going to say, there you go. I knew Montana would have an answer for this. I could see him like it's going to explode out of it.
Right.
Yes.
The elephant in the room.
Yes, exactly. It's
go.
a shame. It was very good in its day, but it's moved on a bit, I think. Yeah.
It seemed like a great. I think there probably are still some people or some organizations using Hadoop or very Hadoop-like.
I actually, if I remember correctly, I saw something about Netflix the other day, and I think Netflix used Hadoop somewhere in the background for something. I can't remember what it was, but I swear it was one of these engineers who'd like revealing, the high-level way that Netflix do things. I could be wrong. I've seen a few people, dishing the dirt. Some guy from LinkedIn was, I think, let go or something like that, and then said, "Here's how it all works behind the scenes." And then there was another guy from Atlassian who did the same thing. So there's been a bit of a culling in the IT industry, and a lot of disgruntled IT people are kind of revealing it. But Hadoop, I'm sure Hadoop featured somewhere in there. And anyway, I digress. I'm sorry. Carry on. Rob Jones, who actually is doing an impressive kind of, I think, Rob, you have to prove you're human every so often because you do seem to be like an AI LLM about business intelligence. It's quite incredible, really. It's just a brain dump out, and it's a remarkable thing, really. Very smart guy.
So we've got our AI doesn't worry about that. Just says thanks very much and moves on, doesn't it? So
what it says is Hadoop is a type of elephant, and that's where it goes. And it's like,
right,
no,
that's where it ends.
We say Rob isn't an AI, but the second he clicked off earlier, I had to recharge his credits. That's what it was. It was. His billing rules keep changing. I had to recharge the AI with some extra tokens.
Well, you've let him out of jail this week as well. He's out in the forest there in springtime, so I'm pleased to see you letting him out and letting him get out.
Yeah, he uses one phone call to ask for more credits.
Like a real boy. Yes. Anyway, come on, let's move on. So.
I'm going to name check one of our other partners here, the Data.do side. That's in terms of getting the data into the data warehouse. They're one of our partners who have some great technology for pulling data out of a wide range of operational systems, particularly SaaS systems, so web-based solutions, software as a service. I'm sure you probably all know that, but so things like Salesforce and Sage and Microsoft Dynamics, any of those web-hosted applications. many of which don't really provide a JDBC interface directly. They'll provide maybe a REST API or some other kind of API to help you to extract data. Data do specialize in pulling that kind of data out and pushing it pretty much wherever you want to push it, including your, that might be a data lake, or it could be directly into a data warehouse if you want to manage the pipeline in there. But getting it into a relational database where you can then start using it for business intelligence. Exasol is another one of our partners, provide a fantastic high performance database specifically designed for analytic processing. So it's a columnar in-memory database. Columnar means, well, we're getting to a level of detail there, but if you think about a traditional database, we usually talk about rows being records, but the record is made up of a number of different columns, and a columnar database is a clever way of reducing the amount of storage primarily that's required to store the data by sort of recognizing, well, lots of the rows have the same value in this column. I'm going to find a smart way of recording that fact. That means I don't have to go and read it every time, because I can just do some clever lookups and things. And then Exasol takes that and puts it on steroids by having the whole thing stored in memory. So it's very fast, which is nice. But I mean, I could put other things alongside there. You could have Snowflake. You could have more traditional data warehouse platforms like Redshift. Lots of other data storage, depending on what fits with your overall architecture.
We've actually had representatives from Data2 and Exasol on before on one of the webinars, and they were very good. They were very, explaining how things work, and that was great.
And they are kind of being queued up to join us again for other topics. So if there's specific questions you'd like to have asked, then please let us know. Obviously, just drop a message through. I was actually over at in Germany at one of the Exasol events they recently had experience, and I was lucky enough at the speakers dinner to sit next to Monty, who was the original writer of MySQL, he was telling me some of the stuff that they've got going on with MariaDB at the moment, which obviously he's gone on and done that. So two of his children have been named after or they've named the databases after them.
Three. He's actually got three.
Oh, he's got three children, but the other one's not into the.
No, he's named a different product by from one of his other children.
Yeah.
And the thing is, the limiting factor there is he needs to have more children, otherwise he can't have more products. So. But that's his life's work done now,
Yeah, but he was a great guy to chat to, and interestingly, obviously MariaDB is one of the most popular databases out there at the moment. It's kind of pushed out on a lot of the Linux distros, and the Enterprise Edition now, they're actually doing some partnership with Exasol. So the queries will come in to MariaDB, and it will then look at the query and go, oh, this is an analytics query, and it will push it to an internal copy of Exasol to actually run the analytics and then pass it back out through the same data connection. So they did a huge look across the market at different ways to speed up the analytics running alongside MariaDB, and they said Exasol was head and shoulders above and beyond anything else that's out there. So we're really proud to have them as a partner and to work with them, and they're doing some amazing stuff with our customers.
A lot of people have kind of focused on MariaDB, and Montana would probably have an opinion on this as well, due to the fact it is completely open source and free. I believe Montana, if you know about this or not, but it's completely free. It's FOSS, I think. Whereas MySQL is the community edition is free, but the commercial edition is owned by Oracle now, I believe.
Yes. So MariaDB Community Server is completely free and open source software.
Yeah, and that was why a lot of people moved to Maria, I think, from MySQL. They are compatible. I'm an expert in MySQL. I did that for a very long time, and I've actually had paid licenses for it as well, and they are not cheap. And did a lot of things, but everything you could do with MySQL, you can do with Maria. DB,
and one of the great thing about the MariaDB Foundation, it kind of mentions in like their constitution where it will remain free and open source forever. So that's really cool.
Right. Yeah. And that's your kind of hook as well, I think. Yeah. For those that don't know, Montana builds his own Linux distribution. That is how Completely open source he is. We should even call him Open Source Montana from now.
There you go.
But anyway, yeah, great stuff. So how are we doing on the slides? We're up to number 4, I think. Is that right? Or have you got more to say about this slide, Rob?
We've got one more topic to cover, which is governance and security. We're going to cover that one today, or shall we come back another time?
I'm fine to do that. I don't mind.
It's quite a big topic.
we're approaching the hour. It might be a good idea to do it maybe next time, I think. If it's going to be that big, you could be talking like 20 minutes or more. So
we could talk all week on this one, but we don't.
Should we give it a quick glance over, and then I think we can always kind of come back to the topic.
Let's cover the headlines, if you see what I mean, which are really on this slide, and then we can talk about it next time, which is a good thing. We can head on to this next time, because actually governance and security is a very big deal at the moment. I think it does deserve its own webinar, because in Europe, for Americans, it's not quite as pressing at the moment, but certainly in Europe, with the software composition analysis rules and all the rest of it, is becoming very, very relevant, big time. You know, like the fines are existentially, you know, you can go out of business if you get fined for breaching this in Europe from September as well. So big thing to talk about, I think. So AI Rob, off you go.
Well, here's the answer.
I'm glad you asked me that. Yes.
It's I mean, the points on here are certainly my attempt to highlight the big topics around this. So data stewardship is, again, probably more of an enterprise topic than an ISV topic, but it's relevant wherever. The theme is basically saying, look, if you want to have good quality data, you need to make someone responsible for that data, and it's going to be their job to make sure the data is good quality. So they need to understand, well, what is it? What does good quality mean for this particular kind of data? They're responsible for things like providing the definition. So someone in a business will certainly say, right, well, I am the product data owner. That means I am the guy who is responsible for saying, what do we need to know about products? What is the definition of this attribute? So if I say supplier, what does that mean? If I say used by date, what does that actually mean? How am I going to store it? What granularity am I going to store it at? Is that a timestamp? Is that a date? Is that what is that? And the same for all the other data. So, if I'm saying, where does it come from? Country of origin. What do I mean by country anyway? That's not quite as straightforward as you might think. When it comes down to the UK, you've got outliers like the Isle of Man and the states of Jersey and all those sorts of things. They're not actually officially countries. But sometimes it matters. So yeah, the data steward is the person who makes those calls on behalf of the business and saying, what do we need to know and how are we going to make sure we've got it? And they also then say, particularly in the case of things like personal data, so like, how is it reasonable to use this data? What purposes can it be made available for? So that might be age, for example. There are many things which you're not allowed to use age for. You might like to, because you might think it would be a good thing to do, but you're not allowed to, particularly in the EU, because of age discrimination policies and so on. So yeah, they will make the call about, is it reasonable to show this data? How can you use it? Identity and access is about saying, right, if someone wants to use your BI tools or any other software tools for that matter, it's about showing, well, who are they? How can they prove that they are who they say they are? And then actually the mechanisms for doing that and for granting them access to your tools. So things like single sign-on, multi-factor authentication. So in our case, that'd be integrating with things like Entra ID, Okta, other tools that that can auth login, things like that, and they can be used to add multi-factor authentication to Yellowfin. It's mostly on the end user tools that we worry about that. I mean, you do obviously want to apply access controls to all elements of the BI stack, because you don't want anyone just wandering in and corrupting your data warehouse. But where it gets most visibility tends to be on the business user side. particularly when it's web facing, and it's really important that you get that right. Role-based access control is really about saying, well, it's a way of viewing, well, how do I manage security? How do I make sure that only the right people in my business are allowed to see particular kinds of data or do particular kinds of things to the data? So again, back to your data warehouse, if you want to be sure the data is of good quality, and we can perhaps talk on another occasion about what do we mean by good quality, but it's things like, is it complete? Are the values in it correct? Are they fit for purpose? All those kinds of good things. If you want to maintain those attributes, you need to make sure that people can't just wander in and start changing the data. There has to be good control over which people within your organization are allowed to do it. And typically it's people in the role of data engineer or some equivalent in your business. Yellowfin as a BI tool also has concept of, well, are you the person who builds content or are you the person who consumes that content? And you'll have different sets of permissions to interact with the content within Yellowfin depending on your role. So at some stage we'll come back and talk at some point about how Yellowfin delivers role-based access control, but for now we'll just say that it does. Row and object security. So at this point we're sort of saying, right, getting into the nitty-gritty of it, I'm into the report. Not everybody should see the same data even when they're doing the same report. So if I'm the product manager for Europe, then I probably or maybe shouldn't be allowed to see the equivalent data for the States or for Australia or whatever. You might make a case for saying maybe they can see the summary data, but they can't see the detailed data. But whatever it is, you can apply the access controls that limit what data those particular individuals should see. So, and Yellowfin provides a concept called access filters, which can limit the data that's actually provided when that particular user runs a query. Auditing and monitoring is a big topic again. So it comes back to say particularly relevant to personal data again, but in general, you want to be able to show who had access to the data and what do they do with it. So usage tracking, good reasons for understanding who had access to this data, where has it gone is one thing, but actually usage tracking is useful in its own right. Understanding which of these reports I built do people actually consume, because you know what, if they're not consuming them, I'm not producing them.
That's actually almost the most important thing, because if you're putting effort into this, you need to know that the effort is worthwhile.
It's certainly important to be able to do that.
You can have KPIs and things like that, but at the end of the day, when you're talking about data, what's the KPI? We've got more data than we had last time. No, that's not a metric that is going to help you. Oh, we've got more reports than we had last week. Again, not a metric, but are those reports that you're creating, or are those stories or any of the other things that Yellowfin can produce, for example, are they being consumed? Because otherwise, why are you putting an effort into generating those things? The answer is either you need to adapt and promote it more so that people are aware of some of the information is available, or you need to stop wasting time on it and focus on something that's actually going to be used by people. So it's a double-edged sword.
But it links back really nicely to where we started the whole session. What is business intelligence? It's about doing business intelligently and being able to make actionable decisions. And if people aren't picking up and using it, adoption is one of the biggest challenges around BI. And that's why things like having it embedded into your workflows, embedding it into your actual applications, and the kind of stuff that you can do with Yellowfin to embed it seamlessly into existing products and workflows is really, really important to drive that adoption. And the auditing and monitoring is how you're going to be able to monitor that as an organization.
By the way, one important thing about governance and security, which applies to the US, speaking as an American for a second, but also speaking as a Brit, it's when something happens, when you have a data breach, or you accidentally email your customer's private data to someone who shouldn't receive it, God forbid, or something else happens where you have actually breached the security of your data. It's one of the few cases where ignorance of the law is no defense. In America, there is a principle of, actually you broke the law, and the fact you didn't know about it is your fault anyway. You should have known that law existed. You should have known that getting in a car and driving drunk was obviously a bad idea. Most people know about that law, but you can't say, well, I didn't know that, I couldn't drink 3 brandies and drive. I mean, there's no defense. There is a limit. It's up to you as a driver to have worked that out. Therefore, there's no defense. But actually, when it comes to data governance and security breaches, there is a fine line between you were breached and it wasn't your fault, but you're still responsible for fines and reparations and, giving people that free, I'm sure you've all had it. Oh, good news, you've got free identity tracking because we got breached. I mean, I get them all the time. I'm sure you do. There's a fine line between that kind of remediation of a breach of governance or security and one where you've actually willfully done something wrong. We don't need to worry about this security. We're never going to have anybody hack us. It's private. There's that is negligence. The other one is unfortunate, but the two actually have very similar penalties. Now, the negligence one tends to go into the realms of criminality, which is much more clearly defined in the United States than it is in the UK. The UK's kind of mashes together, and I'm sure it's true in Europe, mashes together criminality and breaking a law. Whereas in the United States, breaking a law in a civil sense is quite different to criminality. You can have a civil penalty that's dealt with by one set of court systems and a criminal penalty which is dealt with by an entirely different branch of the judiciary. And governance and security is a very, very big deal. That's why I think, we're going to have a whole webinar about it and go into the bit of fear and uncertainty and doubt about this. But unfortunately, it's a real thing.
There's a big trend in terms of stuff moving away from corporate responsibility into personal responsibility around data as well, which is a big thing. But I think one of the key things around auditing and monitoring, just to kind of close that one off for now, is you can only audit and monitor stuff that's within your control. As soon as you start exporting data out and putting it into Excel or PowerPoint or whatever and sending it around on email, that data is now outside of a controlled area. And that's something that is a real thing that people are missing. With Yellowfin, having everything, be able to keep it in the platform, keep it under presents and stories, making sure that if you send the wrong link to somebody, they can still only see what they should be able to see, all that kind of side of things. It's a really important part of making sure you've got that governance story and to cover that risk, because a lot of it is down to risk mitigation. And if you can do that in a smart way, then you're in a really, really smart place. So.
And in fact, I mean, that really goes back to level 1 as well, item 1, which is data stewardship as well. Data stewardship goes into, why are you allowing people to create PowerPoint presentations with this? Should they be doing that? Because as soon as you've done that, you've lost the stewardship of the data and you've allowed someone to just randomly take some of that data, exfiltrate it, maybe with permission, but even so, it's now no longer under your control, because if they download that PowerPoint as a PDF, hand it out to 40,000 people, you may not have wanted that to happen. You could put confidential at the bottom of the slides, but that is not really considered to be data stewardship. That's just, shutting the barn door after the horse is bolted. I mean, actually, I can ask a question of Montana, because Montana's an interesting kind of outlier here in that you are definitely a Linux fan, and I'm going to guess that one of the reasons for your kind of unhealthy obsession with it is, and I'm joking because I love Unix and Linux myself, as we talked about before, but is that partly to do with privacy and data stewardship at a personal level as well? Do you choose that because you don't trust other systems, or?
Yeah, absolutely. So Gentoo is a really great example. Anyone that knows Linux knows that the Gentoo install process is crazy, specifically when you're picking, partitioning and stuff. And all that really is governance, right? Because you want to say, hey, I only actually want, ext3 or ext4 to only talk to these certain files. And yeah, it really is about trust and me governing what can talk to what's walled off from other things. And that's just flexibility that you don't get with, say, Windows or even Mac OS.
Yeah,
And not to bash Windows this whole time, but
well, I mean, it's like complaining about Ford Cortina, which the Brits will understand what I'm saying there. But at the end of the day, as well, when it comes to governance and security, which we are going to focus on next time, actually, it's becoming more of a problem, because if you've got Windows, it's very helpful, and so is Mac OS with Siri's AI stuff. Almost everything that you tend to use that's a big four corporate thing, Microsoft Excel, Microsoft Word, but
Yeah, I mean
actually
the world's economy is in Excel. Like, it's crazy.
yeah, it's all got AI built into it, and really, as the kind of phrase is always, if it's free, then you are the product, and that's really the problem here. Is that data is becoming more and more about a little bit of a war that everybody seems to be fighting. Anyway,
And for the record, Siri is not allowed in my MacBook. I turn her off.
Oh, well, there you go. Well, I unfortunately I have multiple AIs on my machine because of what I do. So okay, so we're going to talk about things like data lineage and stuff like that next time. I think we'll call it a day here, because we're kind of getting to hour and 15 minutes, which I think is quite extraordinary. And Rob, really, we are going to have proof of life at some point to prove that you're not actually an avatar.
He's got to go change his batteries.
How does one prove that one is human? That's a good question.
Yeah, but the quality of the slides is really excellent as well, and I think it's already up to section 4, and everything has been really gold in terms of what we want. I mean, I said before, what we're really looking for is to actually also be able to pull out some of this information as a kind of info shorts, I suppose, video shorts and things like that as well. And there's plenty to mention in there, which is great stuff. Okay, all right, guys. So I'm going to call it a day for now. Are we all okay with that?
Yeah, no, it's been great.
It's been great. Yeah.
Thanks for having us through again this week.
And we'll be back again next time, same time. So if you're watching us live and you're on YouTube, click on that subscribe button. None of us get any money. We're not going to have a little big trophy behind us with the YouTube cool tick on it or anything. It will be the safest way for you to actually make sure that the next time that we're on, you get notified, because Google will do that. They'll send you a ping to say, hey, these guys have gone live. If not, go to our channel and subscribe, and then the next time you open YouTube or LinkedIn or wherever you're going to, it will say, oh, these guys were live. So you'll also catch the replays if we're at a time that's inconvenient for you. We can't be the right time for everybody. Australians right now are probably well and truly asleep. I imagine it's like 4 a.m. for them. But even in the United States, it's still like 8 a.m. for you. Is that right, Montana?
Yep, absolutely.
Yeah, and it's 10 a.m. for me, and the Brits are like, well, we're fine. We've had our lunchtime and all those things. And before we go, we've got I'm going to hide that little link there. It's a bit small, but you can see it fairly clearly. Things. So if you go to, and we've got a new YouTube channel as well, youtube.com, whoops, there's platforms playing out, youtube.com/@yellowfinbi-official. I know it's a big word salad, but if you just remember yellowfinbi-official when you go to YouTube, you'll find us there. Our old channel will have this video on as well, but it'll be a replay only. Due to a technical hitch, we can't use the old channel anymore. LinkedIn.com, go and look for us on there, and also we're on Facebook and X/Twitter, depending on how fond you are of the old days, pre-Tesla ownership / Musk. And next week we're going to have a shorter session because we've got a major event that follows on from that as well. But in the meantime, thank you, Rob, for your wonderful input.
Thank you.
And thank you, Montana, for getting up super early. And
absolutely, anytime.
No, good. We'll do it earlier next week just to punish it. And just joking, just joking. Same time next week. And thank you to Stephen.
Thank you, Ian. Thanks, everyone.
Thanks, everybody.
No worries. And we'll see you all next time. Thanks a lot, everyone. Bye.